So today, we're going to do long division of polynomials, and we're going to time travel back to the 5th grade and do some long division. So we have this fraction right here, 67,508 divided by 21. We should all know that you put the 67,508 inside of the division box and the 21 on the outside of the division box. And we all know that when we think of this division problem, we don't actually think 21 times what will get us 67,508. We don't do that. The long division process usually works like this, where you think 21 times what will get you close to 67, or even easier, look at the first digit, 2, times what will get us that 6 without going over. 3, right? So we put that 3 right above the 7, and then it kind of becomes a distribution problem. 3 times 1 is 3, so you put that 3 right below the 7. And then 3 times 2 is 6, and you put that right below the 6. And we are subtracting. We usually do this and a subtraction sign. However, what I want you to do right now, for the sake of getting better prepared for today's lesson, is to put that 63 in parentheses. I know that looks weird, but it'll really help you in a couple of seconds or in a couple of minutes when we get to long division of polynomials. Anyway, the reason why I want you to put parentheses here, even though we didn't back in the 5th grade, it's kind of like if you were to distribute the minus sign to each term. This is really like a minus 3. 7 take away 3 is 4. So put a 4 down here. And of course the minus right there in front of the 6, a positive 6 with a minus 6 is nothing. You don't have to put anything down here. So what do we do with this 5? Bring it down. Hey, you guys remember. So the 5 comes down. Okay, so you end up with the 45. And again, you could think 21 times what gets you 45, but even easier, just 2 times what will get you close to 4 without going over? 2 times 2, right? So we have a 2 that I write right above the 5, and it kind of becomes a distribution problem. 2 times 1 is 2. 2 times 2 is 4. And we are subtracting, and like before, let's use parentheses with the minus sign. And then it's kind of like thinking the minus in front of the 2, 5 take away 2 is what? 3. Okay, so we have a 3 right here. And the minus sign distributed to the 4. 4 take away 4 is nothing. I don't have to write anything right there. Move on to the next term. That 0, bring it down. We end up with a 30. And again, instead of thinking 21 and 30, think 2 times what will get you close to 3 without going over? 2 times 1, right? Okay, and it's like distributing. 1 times 1 is 1. 1 times 2 is 2. And I know you're thinking, well, why does he say distributing? Just because that'll get you prepared for today's lesson, right? We already know that 1 times 21 is 21. But I'm going through the motions so you could get more comfortable with dividing polynomials with long division. Anyway, we are subtracting with parentheses. 30 take away 21, the answer, the remainder is 9, right? So we have a 9. Bring down the 8. 98. And again, instead of 21 and 98, let's just think 2 times what gets us close to 9 without going over? 4. 2 times 4 is 8, and it's like distributing, right? 4 times 2 is 8. 4 times 1 is 4. We are subtracting. Use parentheses. Now here is our remainder. What is 8 take away 4? That's 4. And 9 take away 8 is 1. So we have the remainder of 14. So back in the 5th grade, you would put your remainder over the original divisor, which in this case is 21. So here's your final answer, 3,214 with the remainder 14 over the original divisor 21. That is the answer. However, the fraction 14 over 21, that could be reduced. So we might as well reduce by 7, both top and bottom, giving us the final answer, 3,214, and the fraction 2/3. Whew, long division. It's long. Nothing short about it. And same thing with long division of polynomials. It's going to be long. But if you understand this, what we did back in the 5th grade, you will understand what we're doing today. Let's actually move on to today, which is long division of polynomials, and let's jump to an actual homework question, number 20. Okay, now I kept the work right here so we could compare with this new fraction that has a trinomial divided by a binomial, 3 terms, 2 terms, right? So first we're going to begin by writing it with the long division box. The numerator will always go inside the box. The denominator always goes outside of the division box. So it should look like this. And just like before, instead of thinking of 67,508 divided by 21, it's really thinking like 2 times what gets us to 6. So in this case, instead of thinking of the whole thing and the whole thing, let's look at the first term, 3x. 3x times what will give us this exact value, 6x squared? 2x, right? 2x. Now, where am I going to write that 2x? I'm going to write it above the other x. You want to stay organized. X's on top of x's, numbers on top of numbers. Like if we had a 2x squared, I would have written it above the other x squares. But we said 2x, so I wrote it above the other x, right? Anyway, again, it's like a distribution problem. Like up here, when I put the 3 right here, it's like saying 3 times 1, which was 3, and then 3 times 2, which is 6. Right here, same thing. 2x times 1 is 2x. 2x times 3x is 6x squared. And that 2x right there was positive, so I'm going to put a plus sign in front of it. And we are subtracting. So let's put a subtraction bar. Let's put parentheses with the minus sign on the outside of the parentheses. Now, here's why I wanted you to write parentheses, because you need to distribute that minus sign. Now, that doesn't make sense on the number 63, but it makes total sense when you have 2 terms in here. The minus sign goes with the 6x squared, so you really have 6x squared, take away 6x squared, that cancels out. The minus sign goes with the positive 2x, it becomes a negative 2x, and what do we get when I go negative x with another negative 2x? Negative 3x. Now, notice, guys, that I didn't actually change the plus to a minus on my paper, right? Because I do it in my head. Now, the reason why I don't actually change this to a minus is because if I make a mistake and I want to look back at my work, it could get confusing whether it's a plus or minus, and it's hard to backtrack. So I just say, you put the parentheses because you know you need to distribute in your head. This is really a minus, which cancels out with that. This is really a minus, so you have a minus. You owe 1x, you owe 2 x's, you're going to owe a total of 3 x's. And then you're going to bring down the minus 7. And once again, first term 3x times what will give us this exact first term, negative 3x? Negative 1. I need it to be exactly the same, right? So negative 1. Why do I need it to be exactly the same? Because when I subtract the same exact value, that's when it cancels out, okay? So anyways, let's distribute. Negative 1 times 1 is negative 1. Negative 1 times 3x is negative 3x. And once again, we are subtracting. Parentheses right there. Distribute, that becomes positive, it cancels out. Distribute, that becomes positive 1. So you have a negative 7 with the positive 1. What do I get? Negative 6 as my remainder. So what do I do with my remainder? I write it over the original divisor. Now, because this is a polynomial, 2x minus 1, I'm going to write the remainder as a fraction, and I need to put either a plus or minus sign, but I'm going to take this minus sign of the remainder and put it as a minus in front of the fraction. Check it out. Here's my answer. 2x minus 1, and then the remainder minus 6, but I want to write it as a minus fraction with the 6 up on top and the original divisor 3x plus 1 on the bottom. So here's my answer. 2x minus 1 minus the fraction 6 over 3x plus 1. And again, if you have a fraction that you could reduce, like on the first example that we did back in the 5th grade, 14 over 21, you could reduce by 7. If this one were like a 9 and all 3 of them were divisible by 3, you could reduce it. But it's not a 9, it's a 1. You can't reduce all 3 of them, so you just leave it like that. That's your answer. 2x minus 1 minus the fraction 6 over 3x plus 1. All right. Let's try another. Now, I want you to copy down this guy up here. Copy it down exactly the way it is. And you don't have to copy down these notes that I wrote down. I'm just going to explain to you what I wrote. The numerator, or the first polynomial, goes inside of the division box. We already know that. This guy's going to go inside of the division box. And you want it in standard form. Standard form means from highest exponent down to the smallest. Now, in long division, you want to represent every single power. All right, so we have the power of 3, which should go first. So this guy should go first. And then the power of 2, and then the power of 1, but there is no power of 1. So you're going to have to represent y to the power of 1 with a 0 in front of it. You'll see in a little bit. But you want to write this, you want to write them in standard form. Highest exponent down to smallest, representing every single power. Okay? So check this out. Move this out of the way. The first one's going to go inside of the division box. What do I write if I want it in order from highest exponent down to smallest? First term should be what? Not negative y squared. 2y to the power of 3. And then the next one? Negative y to the power of 2. And then the next one? Notice that there is no regular y. Right? There is no regular y. So I am going to put plus 0y because there is no y. How could I represent that there is no y? With that 0y. That means that there is no y. And of course we have the plus 25 at the very end. Okay? And we are dividing by the binomial y minus 3. And just like before, we're not going to think of the whole thing divided by that whole thing, y minus 3. You're going to look at the first term, y, and the first term, 2y minus 3. So let's think y times what will give us a 2y to the third? Y times what will give us that 2y to the third? 2y to the second. Where am I going to write the 2y to the second? Not above the 2y to the third, but above the other y to the second. You want to stay organized, right? So we're going to write that positive 2y to the second right above the other y to the second. Do we all understand where we got this 2y to the second from? We're thinking y times what will give us this exact value? Y times this value will give us that exact value. So when I go 2y to the second times y, it'll give me the 2y to the third. So then you distribute 2y squared times negative 3, and that'll be a negative 6y squared. So when you subtract, the negative would cancel out with the positive. When you distribute right here, there's a negative 2 with the positive 2, it completely cancels. But when you distribute over here, you end up with the positive 6y squared. So positive 6, take away 1, that is a positive 5y squared. We're going to take that 0y, we're going to bring it down, plus 0y. And then we think again, the first term, y times what will get us a 5y squared? A 5y. Yay? Positive 5y. And again, we want to stay organized. All the y squares above each other, all the y's above each other. Let's distribute that 5y times y. That'll give us a 5y squared. Let's distribute 5y times negative 3. That'll be a negative 15 with the y. We are subtracting. Put parentheses with the minus sign on the outside. Distribute that minus sign to both terms. The minus sign in here would cause it to cancel out. Positive 5y squared, negative 5y squared. When you distribute the minus over here, a minus and a minus is a plus. Negative times a negative is a positive. So you really do end up with a positive 15y down here. Positive 15y. And you finally bring down that plus 25. Then we think y times what will give us this first term, 15y? Positive 15. So let's distribute this positive 15 times y. That is positive 15y. Distribute the positive 15 times negative 3. That'll give us a negative 45. And we are subtracting. So let's put parentheses with the minus sign. And when you distribute, a minus sign right here would cause it to be negative 15 with the positive 15 completely cancels. A negative over here, a negative times a negative is a positive. So you really have a positive 45 plus 25. That will give you the remainder of 70. So what do we do with remainders? You put them over the original divisors. Now because this is a positive 70, I'm going to put plus after that 15. Put a fraction bar. Put the 70 up on top and the y minus 3 on the bottom. And this right here is your answer. 2y squared plus 5y plus 15 plus 70 over y minus 3. That's your entire answer right there. Now, if this would have been a negative 70 remainder, it would have been a minus 70 over that. Or let's say if it was a negative 13, it would be a minus 13 over that. The remainder is 70, so that's why it's a plus the fraction 70 over y minus 3. Copy that one down. Why are we doing this one? Because it doesn't look like a division problem, but it is. It's a division problem. Why? Because when we did the rules of exponents, we should remember that anything to the negative power, in this case, this guy, it needs to be moved to the other side. The other side of what? The other side of the fraction. So here's a fraction bar. Move this binomial to the other side, move it to the bottom, and here's your real division problem, the 6y squared minus 5y minus 15 divided by 2y plus 3. Anything to the negative 1 power, you move it to the other side, and that negative 1 becomes a positive 1, which means you have no more power. So we're going to use a long division. We're going to rewrite the fraction as a division box with the 6y squared minus 5y minus 15 on the inside and the 2y plus 3 on the outside. And notice that there are no missing powers. You have a y to the second, you have a y to the 1, you have the regular number at the end. This is what we like. If you did have a missing power, like let's say there was a power of 3 and it was missing the power of 2, you'd have to represent a 0y squared wherever there's a missing power. I hope that makes sense. So let's begin. 2y times what will give us that exact value, 6y squared? 3y, right? And we put that 3y above the other y terms. And let's distribute 3y times that 2y we said was 6y squared. Distribute 3y times 3 is positive 9y. And we're subtracting, put parentheses around it with the minus. The minus sign in front of the 6 would be a negative 6, which cancels out with the positive 6. There are no more y squares. The minus sign when you distribute over here is a negative 9y. With another negative 5, what do we end up with?
4.
Negative 14y. Once again, the negative, you distribute it, it becomes a negative 9y with another negative 5y. You owe 5, you owe 9, you're going to owe 14 altogether. Bring down the minus 15 at the very end. And 2y times what will get us that identical value? Negative 7, right? So put that negative 7 over the 15. Distribute negative 7 times 2y is negative 14y. Negative 7 times 3 is negative 21. We are subtracting. Use parentheses. Put the minus on the outside. Distribute that minus sign to each of the terms. So the minus sign right here would make it a positive, which would cancel. The minus sign over here would make it a positive. So what's our remainder? 6. So our answer is 3y minus 7. Because the remainder is positive 6, I want to put plus, and then the fraction bar, and the actual remainder 6 over the original divisor 2y plus 3. And there is your answer, 3y minus 7 plus 6 over 2y plus 3. Everybody try, copy this one down. And I'm going to pause it right now and give you guys a chance to work this out. But before I give you guys a chance to work this out, could somebody just tell me what goes inside the box? Like what goes inside this division box? 4p to the fourth, what? Okay, minus 0, I would go plus 0, but yeah. Minus plus doesn't matter, 0 is 0, right? There is no p to the third, so it's very, very important that we actually fill in that blank spot with the 0 p to the third. You're thinking there is no p to the third. Exactly right. There is no p to the third. 0 p to the thirds means that there is no p to the thirds. So why am I doing this? Because it helps me stay organized. So this is what it should look like. And with the 2p minus 3 on the outside. Now, let me show you what it would look like without that 0p to the third. So here, I rewrote it without the 0p to the third. And if I told you, let's start solving this. Okay, 2p times what will get you 4p to the fourth? 2p to the third. Now, where are you going to write the 2p to the third? You see, it's missing the p to the third. You need that value to stay organized. You need the p to, yeah, exactly. So that's why we love having, or that's why we need every single power represented. Oh, power 4, okay, we need the power of 3. It's not there, I'm going to put a 0. It's not there. But it'll still hold that place value. So when you do say 2p times 2p to the third, you'll be able to write it above that other p to the third. Okay, I want to pause it, keep going, and I'll explain it in a bit. So we begin with 2p times what will give us this identical value 4p to the fourth? Well, 2p to the third, right? You think 2 times what gets you 4? 2 times 2 gets you 4. P times how many more p's to get you p to the fourth, p to the third. So 2p to the third is the correct answer. And you're going to put that 2p to the third right above the other p's to the thirds, right? Right above that 0p to the third. Now we're going to distribute 2p to the third times 2p. We said that was 4p to the fourth. 2p to the third times negative 3, that'll be a negative 6p to the third. We are subtracting, put parentheses, put a minus sign. This is really a negative 4p to the fourth that cancels with the positive 4p to the fourth. This negative sign, when you distribute it, it becomes positive. 0 plus 6 is 6 of those p's to the thirds. Now we're going to bring down the minus 17p squared. And once again, we think 2p times what will get us that 6p to the third? What's that? Plus 3p to the second. Right? 2 times 3 is 6. P times p to the second is p to the third. So we will end up with that 6p to the third right there. But when we distribute 3p to the second, we already did it to the 2p. 3p to the second times negative 3, what do I get? Negative 9p to the second. And we are subtracting, so put parentheses, put the minus sign, distribute in your head. This becomes negative, which cancels out. This becomes positive, so you really have a negative 17 and a positive 9. What do we end up with?
8.
Negative 8 of those p squares. Bring down that 14p, positive 14p. And then 2p times what will get us that identical 8p squared? Negative 4p. So you put a negative 4 and a p right there. So negative 4p times that 2p is the negative 8p squared. The negative 4p times negative 3, a negative times a negative, is a positive 12 with p. Of course, we have the parentheses, the minus sign. Distribute, that becomes positive 8p squared, which cancels with the negative 8p squared. Distribute, this becomes negative 12. So we end up with a 2p left over, positive 2p left over. Bring down the minus 3. So you end up with 2p minus 3. So you got to think 2p times what will get you that 2p?
1.
Times 1. So positive 1, that'll get you the 2p minus 3. And of course, when you subtract, distributing, you end up with no remainder. That means that this is your answer right here. 2p to the third plus 3p squared minus 4p plus 1. No remainder. So that is your answer. Again, I repeat, it's very important that you represent every single power of your original problem, right? You start the power 4. There is no power of 3, so you must put 0p to the third to represent that power of 3. If you didn't have this here, everything would get all messed up, out of order. Everything has to be organized. P to the thirds on top of p to the thirds all the way down. P squares on top of p squares all the way down. P's on top of p's all the way down. Numbers all the way down, right? Got to stay organized. Now, we do have a worksheet on Google Classroom. I didn't print it for you because long division, it takes up a lot of space. So it's better for you guys just to go there, copy down the questions as you work. I do recommend for you guys to do questions 1 and 2 and then skip all the way to 18, 19, 20, 21, 22, 23. Okay? So those are the questions I want you to do. We'll do a couple of them right now. So numbers 1 through 6 are all the same type of question. All right? We do not have a binomial down here. So I don't want you to do long division. Okay? We don't have a binomial. Like when you use long divisions, when you have like 2x plus 3 or x minus 5. Bye. Right here we have just a monomial. So, I mean, think about how ugly this would be if I did long division. Long division, I'd have to do this. I'd have to do, don't copy this down, but just watch me. I'd have to do 15 r to the 10th. Is there an r to the 9th? No, I'd have to do plus 0 r to the 9th. But then there is an r to the 8th minus 5 r to the 8th. And then there is no r to the 7th, so plus 0 r to the 7th plus 0 r to the 6th. Are you kidding me? Forget that, right? Okay, let's not do that. What we're going to do is use a skill that we've already done in the past. Whenever we had something plus something plus something over a single number, we would take that single term and split it up to each of the terms and separate it into 3 fractions. That's what we're going to do here. Check it out. I want to take this 5r to the 4th and I'm going to put it underneath each of these, creating 3 fractions. Okay, so I just split it up, created 3 fractions. Now, why would I do that? Because of the fact that I did not have a binomial down here. When I split it up, I now have fractions that have pure multiplication, which means that we could cancel things out using rules of exponents. So I could look at that first fraction and say, okay, well, the 15 divided by 5 is a nice number 3, and it's left over up on top. There's 4 r's on the bottom that cancel with 4 of the 10, which means I have 6 left over up on top. So the first answer is actually 3 r to the 6. No more fraction. There was nothing left on the bottom. The second fraction, 5 cancels with 5. 4 r's cancel with 4 r's. There's 4 r's left up on top. So we end up with minus r to the 4th. And then the last one, the 40 and the 5. 40 divided by 5 is 8. 2 r's cancel with 2 of the 4. There's 2 left over. So on the last one, we do have a fraction, 8 up on top over r squared. There's your answer. It's a heck of a lot faster than long division. Yay? Okay, now, number 2, you're going to do it the same exact way, but this is really not long division. I don't recommend long division right here. So we're not going to do questions 3, 4, 5, because they're all the same. They're all one term. Look, 2km squared, 6x squared y, 4a, right? So let's just do 1. I already did 1. You do 2. And then let's actually move on to the ones where we actually have to use long division. Whenever you have something divided by a binomial, like right here, it's divided by 2y plus 3, you need long division. Right here, it's divided by 2x minus 3, you need long division. Right here, divided by 3x plus 1, you need long division. So what I would like you to practice, and the answers are on Google Classroom, is try number 2, check your answer, and then do 18, 19, 20, 21, 22, 23, and you can stop right there. And with that, you should be ready for the long division questions on Friday's quiz. Now, tomorrow, we're going to cover a section that's way easier than this one, way faster than this one. You're going to love it. But then, that's it. We're done for the entire semester.